Ruckus switches, Ruckus ICX switches, specifically switches running 8080 or later. There's been some changes to the configuration steps required, and we've done a lot to make it more efficient. So again, what I'll do is I'll cover it based off this relatively straightforward basic site example where we've got a data and a voice VLAN. We'll assume that users have IP phones, so we'll actually have the voice VLAN tagged on a port, and then we'll have the data VLAN untagged. So again, that'll be a voice VLAN port. We'll do that on the first, we'll go with 4 ports on this particular example. We'll do a couple of ports that would be printers and projectors. Again, these will all map to VLAN 15. And then I'll also do, on my last, we'll call it 8 ports, we'll do a VLAN pool for our access points. And this will be for VLANs 30 to 35, representing a pretty typical higher scale deployment where we need more than one VLAN to support the number of users on a Wi-Fi network. Right-hand side of the screen here, I have an ICX 7250. It's a 24-port PoE switch running router code, so SPR. So the R is router, meaning we have layer 3 capabilities on 8080 beta. This is not currently the latest version of code, but this will suffice to show all of the configuration steps for 8080 or 8090. So again, when we get started, we'll start by actually building and naming the VLANs, and so we can do this in a couple of ways. So hop into config mode, just like we would with other switches that you may be familiar with, and we will create VLAN 10, we'll call it data. Go ahead and do VLAN 20, call this voice. Create the printer VLAN as VLAN 15, and we could have done these in a sequence. I'll show you what that looks like a little bit later, but then we'll also build the VLAN pool while we're here. So we'll do VLAN 30 to 35. We'll name this just Wi-Fi. And so again, what we're going to do is build out a basic kind of campus infrastructure. This would be an example edge switch. So I'll start with my first, I think I said 4 ports earlier, but we'll actually do the first 8 ports as example voice ports. So for that, what I want to do is actually go into, we'll start with VLAN 10, that'll be our data. And so I want to say make these untagged ports. And so again, that's the equivalent of a Cisco access port. Really just meaning we're not expecting a .1Q tag, and we'll do a range. So we'll say untagged Ethernet 111 to 118. We'll see that added untagged ports 1 to 8 to port VLAN 10. And so if we were to plug in a PC to that port directly now, it would be mapped into VLAN 10, again with no .1Q tag. What we also want to do is add phone support while we're at it. So what we'll do is we'll hop over to VLAN 20, and we'll take those same ports and say tagged Ethernet 111 to 118. Okay, and so now we have added the tag ports 111 to 118. So an IP phone plugged in, configured to be tagged on VLAN 20 will be able to get its appropriate IP address, pull down configuration, send all of its traffic on VLAN 20. The nice part is that anytime that we have a tagged port, we actually trust the .1Q precedence bit. So the QoS is actually built in for most IP phone systems without you having to make any other configuration changes. Go ahead and save the config while I'm at it, and we will move over and do the next 4 ports as printer ports, and we'll do all of these untagged in VLAN 15. And this will look just like the config example we did earlier. VLAN 15, untagged Ethernet 11. We'll go with port 9 to 12. That'll be the next 4 ports in order. Those are untagged. So again, if we plugged in a printer or a projector, they would get mapped into VLAN 15. And then we'll go ahead and actually do the VLAN pool for the Wi-Fi next. So again, we're able to do multiple VLANs at once. So we'll hop back over and say VLAN 30 to 35. We'll do tag Ethernet 11. This is a 24 port switch. So we'll do 1116 to 1124. And what you'll see is that we actually map per line the ports to the VLAN. So you'll see that port VLAN 30, 31, 32, 33, 34, and 35 all got mapped. Kind of as a point of reference, typically on an access point, you have some untagged management VLAN. So actually, let's just go ahead and create that while we're here. So we'll do VLAN, we'll call it 99, and we'll name that Wi-Fi management. And we'll go ahead and do actually do a shortcut here. Instead of doing tagged, we will do untagged. Pull that space out. And so now we have ports 16 to 24 on a Wi-Fi management VLAN of 99 for the APs to call home to the controller, do any of their management functionality, and then we would end up mapping the individual SSIDs to this particular VLAN pool that we have available. The other thing we should probably do for running router code, we need to keep in mind that spanning tree is not running by default. So what we'll do is actually see if we can't get all of the VLANs covered in just one or two commands. So we'll do VLAN 10, 15, 20, and then 30 to 35. And again, it's kind of showing the power of the multi-VLAN configuration steps. We're going to 10, 15, 20, 30 to 35. Anything we do here impacts all of the VLANs. So if we tag or untag, we have to keep in mind that they would all be tagged or untagged here. So make sure that the scope that you have is appropriate. This is also a nice way to go ahead and do a tag for an uplink port, though I will show another way to do that that maybe makes it a little more efficient, and so you don't actually have to know what this list is. So here we'll do per VLAN rapid spanning tree, or the standards-based version, which is 8021W, and we'll assume this is a edge switch, and I would prefer that it not become root, so I'll go ahead and set its priority to 40,000 while I'm at it. The default's 32,768, so if we do it as 40,000, that'll ensure that this guy does not take over as root, even if we haven't configured a lower priority for the existing root switch. So at this point, if we go back, look at a show run, what we will have is a number of VLANs that have all been named. We have port lists associated with the VLANs, data, printer, voice, and then our Wi-Fi pool. See that all of our .1 or 8021W configuration came through, as well as the priority. And then we also have our Wi-Fi management. I think I missed that one, so we'll say VLAN 99. And same thing, we'll go ahead and pop in the spanning tree configuration. And now we've got our full VLAN list. We'll assume this is an edge switch, and so the next thing we need to do is give some configuration for this edge switch to be able to communicate back up to a core. And if we look at an interface list, what we have is we've got a number of RJ45 Ethernet ports, and then we have actually 8 SFP-based ports. And so in this example, I'll go ahead and assume that 121 is my uplink backup to the core. And so what I'll do is, instead of doing the configuration from the multi-VLAN config mode, which would 100% work, we'll actually utilize one of our newer scripts to do that for us automatically. And so I'll actually hop into interface Ethernet 121 and then use the VLAN config workflow. And what I'll do is I'll say add all tagged. And what we'll see is that now ports 121 has added 10 VLANs all tagged. Again, this is kind of what an example uplink configuration would look like. We want to obviously match that on the other side as well to make sure that we have the VLAN tagging matched on the uplink. If we were communicating with a Cisco, typically they are going to want to have at least one native VLAN. Or I'm sorry, they're going to want to have a native VLAN. We would need to match that on this side with our equivalent, which would be an untagged VLAN. So if that happened to be VLAN 1, you would want to make sure that you did an untagged Ethernet 121. If you'd set the default VLAN to be something else, you just have to change that to match. So again, covered just the basics of creating VLANs, turning on spanning tree, associating the VLANs with interfaces. That should be all of the basics that you need. Beyond that, there's a number of things. What I will do is actually go ahead and create, just to show what it looks like, a quick, do a layer 3 interface, and we'll do that for the management network where we're at it. So let's just hop into VLAN 99. Keeping in mind that this config syntax is only applicable to router code. So what I'll do is actually build a router interface. It's called VE99. Then I'll hop into that interface, so int VE99, and then give it an IP address. IP address 99.99.99.1. I'll make that a slash, I don't know, 26 where we're at. Adding routes would look just like any other system. If we're doing a default route, IP route, config mode, IP route 0000/0, and then we would give it some next hop. In this case, I've got management running over my home network, so I'm not going to add anything on the 99 network, but just for example, I'll do a default route to my default gateway at the home network 10.0.0.1. At that, again, write mem, and that should be it for VLAN configurations. Thanks for taking the time to listen, and we'll do another one soon.